Thanks for joining us this lunch seminar. Let me introduce myself first. My name is Titia Wouters. I'm program manager of the program Via Water, which is hosted here by UNESCO IHE. I very briefly outlined the main components of our program. It's a program that supports urban water innovations in 7 African countries. We have a fund available from the Ministry of Foreign Affairs from which we can support those innovations. We work together, of course, with UNESCO IHE, but very closely with Akvo for All. Dick Bouwman is one of our colleagues, and together we team up to have all these innovations realized in 7 countries. We focus on urban so-called pressing needs, urban water pressing needs, which can vary from issues around groundwater, water quality, flooding, sanitation, drinking water. It's a whole list of 12 pressing needs where our program focuses on. I don't want to take too much time from Hans. Check our website or drop at our office. We're on the 3rd floor next to the Human Resources Department. If you have any questions or any innovative ideas that you would like to be supported by our program. But today we're here more on the content side. And I'd like to invite Hans Merton. He's from Akvo. He will explain you a little bit more about what Akvo is. He is a geohydrologist, studied here in Delft. I will give you about half an hour and then give some time for you to ask questions. Although if you have, during his presentation, if you already have some questions, please don't hesitate to raise your hand and ask them. Yeah? Shall we try to move into your presentation?
Yeah. Well, teacher, thanks. Keep the introduction short. This is our team, about 80 people in staff at this moment. And Akvo, by the way, Akvo is the word water in Esperanto. It's not an abbreviation, it's water in Esperanto. And Akvo was founded in 2008. It's a foundation. As I said, worldwide 80 in staff. And Akvo develops open source internet and mobile tools. And basically what we do is we enable our partners with our mobile solutions to collect data and information at scale, relatively quickly, efficient, which supports them in efficient programming, knowing what really is happening on the ground, because lack of data is usually in a lot of development aid programs a huge problem. So what we do is we fill that niche of data, efficient data and information collecting, enabling our partners to do efficient programming. So we play that sort of intermediate role with our tools. And that indirectly, naturally, supports more efficient monitoring, transparency, accountability, because people really know what is happening at the ground, sometimes even real-time or near-time data. And our tools are cross-sectoral, so you can use them in wash, renewables. It's not specifically tailored to one, sector. We're working from different hubs. Head office in Amsterdam, but our regional hubs provide local support in East Africa, West Africa, and the different regions around the world. So that's where really the programming are being executed. We train our partners, like UNICEF, like lots of partners. We train our partners locally to use the tools that Akvo provides. And then they go out in the field to do the actual data collection. And actually, the reason why 2008 Akvo was founded, I think you recognize this. This is already partially, luckily, history, but still, there's a lot of ineffective reporting, data capture. Things can still improve dramatically at scale. But today, we're not talking about Akvo as an organization. Basically, what we support, we're focusing on Caddisfly, more to be followed on this. Basically, what we support with our tools is the following process: capture data in the field, make sure you transform that data into information that you can understand what is happening, and then use that information to steer your program and actually share that information in an efficient way online with your stakeholders. This is basically what we support with our tools. And that's sort of the following process: collecting data using your phone. Most of our tools use simply an Android phone as a point of entry. Install a survey on your phone, take the phone out into the field, open the survey on the app, start filling in questions and answers, and the phone uploads the data to the Akvo Flow platform. So that's basically what happens. You collect data in the field, the data gets transmitted through the network to Akvo Flow. That's basically a big open data platform, and from that data platform, in several steps, you can start analyzing and visualizing your data and share it online with the different stakeholders. That's basically the whole process that Akvo supports. And we do that at scale. Mali, an example of a national water point exercise in Mali, mapping baseline infrastructure. This will be done at the end, like 40,000 water points will be mapped. We're mapping the baseline infrastructure in Nigeria, 500,000 water points. So really it's about mapping at scale what is actually present in the field. This is a short overview of the different countries where Akvo Flow, the underlying data platform, is being used at scale for mostly the darker colored countries at nationwide mapping of WASH infrastructure. An example, a data point, 3.1 million. A data point is a survey executed at a specific geolocation. So somebody opened a survey on the phone, filled in the answers, uploaded the data to the platform. At this moment we have about, we're approaching 3.2 million of those surveys executed. So that's sort of indication of the scale of which Akvo Flow is currently being used. What we discussed, like I think two years ago, if you're out in the field, you're already doing a survey, you're at a well, and you're mapping baseline infra, pump type, when was the wall installed, etc., etc. It would be great if at the same time you could use your phone to do a simple water quality screening test. Most of the costs is logistics, people getting there, organizing the whole thing. So the moment you're there with your phone, you're able to do a test at the same time. That's highly efficient, and it would create an enormous advantage to be able to do that. So that's where we started thinking about how could we use a smartphone and transform that smartphone into something device that you can use to do relatively simple water quality testing. That's where the idea of Akvo Caddisfly came from. And Caddisfly, for your information, Caddisfly is a bug. It's a fly that can only reproduce in fresh water, which is very clean. So it's a sort of bioindicator for environmental quality. That's the background of the word Caddisfly. So we thought, what if we could transform this phone, Android, we're not developing for iOS because it's too expensive in developing countries, so it's all Android based. What if we could change that device into something that could measure lead temperature, that could measure more complex parameters like fluoride or arsenic, or even fecal or total coliform, but also relatively simple tests like pH and nitrate, nitrite, etc., etc. What if we could do that? Then we have a very powerful combination between a phone, a data platform, data visualization, and data sharing online. Then suddenly it becomes some sort of a solution. Whereas a lot of field kits don't have the underlying data platform, you have an isolated result on a PDF or a mail or whatever, but you don't have the data solution behind it. Or you go to a lab, which is expensive, takes time, but you also get a PDF result. You can't scale it up. So that was the idea behind it. Now, what we developed is a concept in which you said, what if we're going to use the camera as a colorimeter. Simply use the camera of an existing piece of hardware. Use the flash to illuminate a sample. These things get better and better every day. So the processor gets faster, there's more storage capacity, the cameras get better, and we don't have to do anything about it because it's Samsung and all the Android builders who are doing this for us. So this one gets better and better. And we're simply following that development. So we use the processing capability of the phone, but the important thing is the phone knows where it is, because it got the GPS. And we can also use the transmitting capacity of the phone to upload that data to a data platform. So that sort of provides the building blocks of a very powerful solution. What we developed is based upon three sort of technology pillars, you could mention them. It's colorimetric sensors. So we take the phone and we connect a tailor-made piece of hardware. We call this the testing chamber. We simply connect a tailor-made piece of hardware to the phone, which suddenly transforms the phone into a colorimetric sensor. We install an app on the phone who's managing the whole process. But then suddenly a standard Android phone gets transformed in a colorimeter. Now, this is a solution with using a back case and the phone itself. This was the starting point, but not as scalable as we wanted. The next version we developed is an external camera, which we control the hardware, and you can simply connect to the phone through the micro USB port. And then this is suddenly a standardized piece of hardware instead of a Samsung phone, a Moto G phone. We bypass all the hardware changes, but still we use the processing capability, we use the same app, etc., but only an external piece of hardware. And communication goes empowered through the micro USB port. So that's the colorimetric solution. The second one is we thought, well, if you want to use a strip test just for simple field screening, I mean, it is not an accurate measurement. Basically, it's a screening, low, medium, high concentrations. It's not lab quality, but it's better than nothing. And you could optimize your monitoring program. You start doing screening with a simple strip test, and then still you could select some samples for further colorimetric testing or lab testing or whatever. So that would it would have a good contribution to a more efficient monitoring program. So what we developed is a sort of standardized color reference card, and this color reference card has standardized RGB colors. Basically what you do is you open up the library, and we use off-the-shelf test strips. These are made by Hach, but they can be any supplier, La Motte or whatever. You simply dip the stick into the water sample. You put the strip test on the color reference card in this black area, and then the app starts reading the strip colors, starts comparing them with the RGB values, and then it sort of replaces the subjective human interpretation by a more objective, automated interpretation. Naturally, it's never better than the quality of the tester. That's a limiting factor. But suddenly, this test strip becomes part of a solution because it's in the phone, it's got GPS, you can upload the data to the data platform again, and you can visualize it on a map. So then this simple thing like a test of 30 cents, 40 cents per test becomes a simple field screening indication of water quality. And you can use basically anything that is already available on the market. And this is really, really simple to do. You can teach it anyone in half an hour how to do such a test. And the phone calibrates itself before each individual measurement for light conditions, color, etc., etc. So there's calibration for each test. That's what we call the human assisting apps. And the third one is connected sensors. We started like a year and a half ago with the development of a low-cost temperature EC sensor. what we aimed for was like trying to produce something at variable cost of 10 euro or 15 euro, something like that. Much, much lower than industry standard temperature DC conductivity sensors, which are way, way more expensive. But the advantage is, again, it's connected to a data platform if you connect it to your phone, and then the data gets uploaded again. In this case, the intelligence is in the sensor, and the phone simply reads the result. It's a CSV file. CSV data file simply reads the result from the sensor into the app and uploads it to the Akvo data platform. The other two, the intelligence is in the phone, because then the app does the work supported by the processor in the phone. Now, these three represent, in principle, a scalable solution. If you want to do colorimetric testing, you use the testing chamber and you use a reagent, depending on the type of parameter you want to test. So we have a colorimetric test for fluoride, like 0.1 ppm accuracy. We have a test for residual chlorine, very useful to test in, for instance, refugee camps. Doctors Without Borders is going to pilot this in Tanzania. And you simply put the reagent capsule. You simply put the reagent capsule in the testing chamber. Put the water sample in. You put the reagent in. Close the tip. The reagent gets released into the sample. And then at the bottom, the camera starts reading the colored sample through a colorimetric test. So the moment you have different reagents for different parameters, you use the same hardware, you calibrate the phone, and you make sure that the phone is capable of reading fluoride, reading residual chlorine, reading phosphates at accurate levels. So this is in principle scalable. Different parameters for test strips, different colorimetric tests, but also different sensors. We developed an EC sensor, and we are talking to different suppliers. Eikelkamp, we'll be talking to HANA and SensorX. They have off-the-shelf sensors. The only thing that we need to ensure is communication between the Caddisfly app and the Akvo data platform. What we learned is that developing this is really nice, but it's a hassle. It's a lot of work, and you really have to put a lot of effort in getting it sort of close to industry quality. It's a tedious job that you need to do. Well, we've managed to develop something that is really good, but we're not going to do that for 20 other different sensors, turbidity or dissolved oxygen. It's way, way too complicated. We're not going to do that. So for the colorimetric testing, we have a fluoride test with different reagents for the low concentration and higher concentration. We use the back case, but we can also use, this is sort of near to finalization, this is still a prototype, but we can also use the external camera solution, which is much better scalable because this one is calibrated instead that you have to calibrate the phone, which makes it much more scalable. We have a free residual chlorine test that we're going to test with Doctors Without Borders. We're working on an arsenic test. I'll tell a little bit more about that. And we're also working on a colorimetric fecal and total coliform test. I showed the external camera solution to you. Some homework we did on the residual chlorine test. We got the tablets that Doctors Without Borders uses. We tested them and compared them with a HANA probe. We got a correlation of about 0.8, top left. And with two different reagents we tried using this testing chamber, we went up with a correlation of 0.8 to around 0.9. So our colorimetric test at the phone is more accurate than the current DPD tablets used by Doctors Without Borders. And the advantage is on the phone. It's got geolocation, so you have a data solution. So this is going to be piloted soon. What we are working on for arsenic, having the capability of testing fluoride, arsenic, and fecal and total coliform. That's a sort of dream combination worldwide. What What we're working on is a prototype for an arsenic test on the phone, colorimetric test, by using modified nanogold particles. The current tests that are available, there are several, but they all have their pros and contras and not a data solution. So what we're working on is a colorimetric test based upon two principles. Make sure that you modify the size of the nanogold particles in a specific way. You need a specific size between 5 to 10 micrometers, and then make them only receptive for arsenic. So it's a two-step modification process of the nanogold particles. Now, we're working on the proof of concept for this. It's a test that is very sensitive to pH, so you really need to control through a buffer solution. You really need to control the whole process. It's very sensitive to particle size, and yeah, it's under construction. We have the sort of basic principles in our hands, but we're not ready up to a point where we can really start piloting this in the field. Large advantage of this would be a single reagent test instead of a complex field kit with all the different steps and risks involved of using this in the field. The same we're doing with coliform. The coliform test is based upon two principles. You take a water sample, you put the water sample into a broth that accelerates bacteria growth, and the acceleration of bacteria growth generates turbidity. And we control the optical recognition process by the phone already through the app that we developed for the colorimetric testing. So we know how to detect color change. And we also add a reagent which also provides a color change. So it's a combination of increased turbidity and color change that we analyze and detect with the phone. That's what we're doing. So we have a working prototype for that, and you see some elements at the top side. What we do is we filter 100 ml sample, because that's where the count is based upon. We filter 100 ml sample to concentrate the bacteria which are already present in that sample, and then put them into the right broth and in the right color reagent. And that means that we're working on an early, sort of quick early detection, presence-absence test. We're focusing on about 2 hours instead of 18, 24, depending on the different type of tests that are currently in the field available. So that's what we're working towards. And what we're doing is taking two samples, do a parallel test at 37 and 44, 37 for total coliform, 44 for fecal. So we simply take a duplo sample, and that means with one and the same sample you can have an indication of both fecal, but also total coliform. Now this is a step further than the arsenic test. I think by the end of this year we will be able to start with field piloting for the prototypes we have for this test. An example, in four different types of bacteria. The left-hand side, coliform, and on the right-hand side, two different types of bacteria. And you see that the broth we use in combination with the color reagent, it's only sensitive for it's only sensitive for coliform bacteria. And the most significant color change is in the E. coli, at the top left-hand side. We're drinking this water in India at our lab in Bangalore. And this is the present coliform bacteria in the bottled water that we drink in Bangalore. Not really clean either. The strip tests. Now, basically, what we do with the strip tests is that we simply read them into a library. We enter all the different reference colors into a library by using the color scan. We provide standard solutions, dip the stick in so that we have the accurate color. Then we read the colors with RGB scanner, we enter those RGB values in the library so that the app knows which color belongs for which parameter and which producer with which concentration. So that process takes about an hour and a half, 2 hours to enter a new test into the library. And that's basically a relatively simple process. The app, before you can do a measurement, and you see an example, before you do a measurement, the app controls light, colors, has a different set of tests in order to be sure that the result you obtain is accurate. So that's a built-in calibration for each individual test. And basically that's I think the handy thing. It's very simple. The sensor testing. I showed you the EC sensor. This one is, or a previous version of this one, is being used in Texel, in the province of North Holland, in a polder by farmers. They're simply testing surface water quality on EC by dipping in the sensor and uploading the data to the Akvo data platform. So that's an example of, call it participatory data collection. Farmers using the surface water to irrigate their crops. They don't want to have soil damage. And the water board doesn't want to be liable for providing surface water with a two saline quality. So there's a shared interest between the two. And the data resulting from this test is uploaded and immediately published in an open data platform. It's a map which is accessible to anybody. And naturally what you see, you get competition between farmers who are uploading the most data on a weekly basis. So this works. And what we are looking for is other sensors. Perhaps stability, dissolved oxygen, if you look at the SDGs. And basically that could be done through the micro USB port or audio or Bluetooth. There are different solutions. We chose for the micro USB port. It works, but it also has a disadvantage. It's less durable. You really have to be careful with the port. If you want to demolish it, it's relatively easy. So Bluetooth connection could be better, but then again you need a powered sensor, and this one is not powered. It gets its power from the phone, and that's an advantage that this one has. And I think almost final. We also did a pilot in Burkina as part of let's say peri-urban water service delivery. We installed a number of water level sensors in a well, in observation wells, and that data gets uploaded automatically to a data platform, and then you have real-time information on the actual water levels. Same idea is how can we support better management of local systems, 3,000 people, 5,000 people, relatively small peri-urban systems with a well and a small pipe network with a limited number of observation wells, how we could help those parties that are responsible for managing those systems with actual data. And we're using this solar-powered panel for this. And underlying all the hardware that we develop, we're using Arduino building blocks. They're open source. Basically everything that Akvo develops is open source. So all the software solutions are open source, but also all hardware. All hardware designs are also open source. So anyone can go to GitHub and download the production files of the hardware. We share everything. And we're using Arduino PCBs, etc., to develop this and standard solar-powered systems.
Hans, what's the size of this sensor?
The
size of this sensor?
Of this one?
Yeah.
It's about this.
And the length?
Yeah, what we found out in the test in Burkina Faso is that what you should do, everybody knows the creativity in Africa. You always find a solution in a piece, in a pipe or whatever, and somebody starts welding and making something. So we only provide the top part with simply slangenklem, something that you can just hook up the transmitter to any type of diameter pipe. We're not going to provide the pipe, we'll just provide the top part.
Yeah.
That's it. So this is the sort of current an overview of the current parameters suite that we support with Caddisfly connected to Flow. Yeah, and some on the roadmap. Next step, we're going to start pilot in Punjab, supported by the World Bank. Punjab has a lot of groundwater problems, not only fluoride, but also due to lots of industrial activity, arsenic problems. So Punjab has a lot of elements of the periodical system, unfortunately, in the groundwater. So we're going to start a pilot using Caddisfly and participatory data collection in Punjab. The next steps, develop high-fidelity prototypes ready for manufacturing distribution at larger scale, and the most important ones are fluoride, residual chlorine, EC, and strip testing, because those are the parameters most progressed. Continue with the R&D on arsenic, coliform, and other work. In 2017, add a new number, a list of other parameters. For instance, phosphates. Strip tests are nice, but the range doesn't fit the European Water Framework Directive. It's about 1 ppm, 0.1 ppm, close to detection limit. Whereas the first patch of the strip starts about 100 ppm or 50. Doesn't fit with the monitoring requirements. And basically, as I told you, at TESOL, we start from the development aid sector, but we could also monitor surface water quality in Europe. And monitoring obligations of the SDGs is not limited to the development world, to the developing countries. So we're going to add some parameters like phosphates, and we're working on a colorimetric test for phosphates, like we've done for residual chlorine, to make it much more accurate. For instance, soil testing, pH and pK, using the same color reference, using the strip test solution. We then use off-the-shelf strip tests. Now, we're working on that to see how accurate they are and how complex the sample preparation is in order to be able to do such a strip test. But that's the homework we're doing currently now in our lab and also with external labs to see whether we can develop something that is enough reliable using a strip test to do that type of testing under development. And then actually cooperation. We're working with the Indian Institute of Science on the coliform test, with the Indian Institute of Technology in Kanpur in India on the arsenic test. They help us out with also lab facility. For instance, to do analysis on the particle size distribution, which is very complex. The modified nanogold particles that I showed you. TU Delft helped us out with validation of the strip testing through a PhD student who did experiments with students. UNESCO IHC supported us with a lot of lab facilities, so we have done extensive testing on the EC sensor and other tests here in Delft through interns. So we get a lot of support from UNESCO IHC too. And what I told you is sensor solution providers connect our platform to companies that already provide the different opportunities, different sensors. And that's so there's a lot of things parallel. On the one hand, upscaling, finalizing prototypes for tests like fluoride. That's one track in bringing those to the market. Second parallel track, doing R&D on arsenic and advanced R&D on arsenic, coliform and all the other tests. Adding new parameters based upon technology we already know. And then naturally connecting sensors. And getting money in to fund to fund future R&D and all the other activities. So, yeah, that's a bit of the overview of the whole program.
Thank you very much.
5 minutes left.
5 minutes left. Well done, Hans. Yeah, so we have some 5 minutes left. Can I open the floor for any questions you might have for Hans? Yes, please.
Thank you for your presentations and interesting work of producing such a database. But I have small questions about how reliable is data that you are collecting data from different sources and different locations, and also the precise of the measurement compared to the traditional laboratory tests, especially for water parameter that it is with a very low range.
Yeah.
And also if there is any specific program that you are using for managing this huge data.
Measuring the?
Measuring the data, managing.
First of all, we are not building lab equipment of lab quality. These are field screening tests, and depending on the type of parameter, we are more or less further away or closer to lab quality. For instance, our fluoride test, I can share an article with you. The fluoride test really approaches lab quality. 0.1, 0.15 ppm accuracy, validated in different conditions. So that's relatively good. We are not using Caddisfly to monitor drinking water. That's coming out of a piped system. You shouldn't do that. You should go to a certified or accredited lab. We're not going to do that. We are monitoring groundwater, which is used as a source for drinking water, or surface water that is used through an intake. So that's Caddisfly is really meant to do screening, and depending on the pipeline, more or less accurate. If you look at the validation, there's in the let's say the testing process itself in the app, there's a number of steps built in to make sure that the interpretation is done correctly, like in the strip tests, and naturally you have to recalibrate. After a while, you have to do a check through calibration of the hardware devices and the sensors. Like any EC sensor, you have to recalibrate it after a certain period of use. So that's something that there's two ways. There's one validation. There's one validation step in the software. There's an additional validation in repeated calibration over time, and naturally also in the data cleaning. You can do from once the data is uploaded to the Akvo platform. That's also a step that is built in. But we have to learn on the longer term, because we're now working like a year with the fluoride test and like half a year with the EC sensor, how they drift over time, yes or no. That is still what we are really experiencing in daily reality. So we're not ready. It's not a product you can buy online from a web shop, which is presented to you 24 hours later. But in 2017 we're getting close. We're getting close to that. Does that answer more or less your questions?
Management.
Okay, thank you.
The management might be of interest. The data management.
Data management is basically the phone only uploads the data to the Flow platform. The phone is simply the entry point of the data. And after that, in the Flow platform, you can do, in combination with Akvo Lumen, you can really start analyzing the data and visualizing it. So it's not, let's say, the front end on the Caddisfly app. You really have to do that in the data platform itself. But Flow is not it's not a database, it's a data platform, and you can basically also use Flow to export the data in different formats and import it in your own software that you're using for further analysis. So we're not focusing on developing sort of the generic solution that everybody can use to do proper data analysis, data visualization, etc. So we have API, so you can basically export the data through API into your own platform that you're already using. So you should really look at these solutions more as a smart way of collecting the data. And from that point onwards, you bring it to your own system and then start using the tools you're already using. That's the split that we specifically made because we're not content specialists. That is the people who are using the tools and using the data in their programs.
I see one more question here. Who else? Oh, wow.
Oh, maar,
Chris, jij moet zo weg.
No, go ahead.
for the student from the first.
Yes.
Yep.
Yeah, I want to ask, sorry, Mari Castro from Unesco. I wanted to ask if, related again with this reliability, if the data has been used, for example, in a case of civil action in Africa or somewhere else. Because if you don't have data that exposes that there's some kind of contamination, either in groundwater or something like that, has been used the data in this case for a legal action.
Not at this. I haven't been into that case, but our position is, if there is an issue, you'd rather have a discussion based upon facts. You'd better have a discussion based upon facts than based upon opinions, and then naturally the facts should be presented in a proper way. As you know, it's not a GCMS accuracy, but it should be reliable enough. So what we aim for with all our tests, to have at least like a 90% or 95% accuracy compared to industry standard. Not like 50 or 60%. No, we should be close to that. That at least the value itself is not open for a lot of debate. But we feel the added value is not in the 0.1 behind the comma accuracy. The real value lies in having data at all, at scale. Better slightly less accurate data over a large area than having no data and having a discussion based upon opinions instead of facts. So that's the process what we support, and that's why we advocate to openly share that data online, because then it becomes much more powerful for debate between people with different interests. But you know, it depends on the situation. We don't own the data. The partner who is using our tools owns the data, and they decide whether to publish it, whether it's open or whether it's closed. We can't force them. We try to convince them of sharing it, but they own the data. We only provide the solution. Does that answer the question?
Two more questions? You have one? Yeah?
One,
Yep.
is it
And
possible?
then the lady in front, and then we'll leave it to that, okay? Because of time.
Is it possible to add data to your platform that I haven't used your cell phone with? So I go into the field, do field measurements,
Yeah.
and I have a lot of data that I want to share with the world.
Not to. It's possible because there are a lot of in the Flow platform you can. But what we then do is mirror a sort of question list
Right.
with the existing data set, because there are a lot of access databases in many countries, which a lot of money has already been going in the previous years, and we don't want to replace that. So it could be two ways. The flow data is added to those existing data solutions through the API, or vice versa, we create a mirrored survey and we upload the data from that existing access database into that mirrored survey, and then the mirrored survey gets into the data into the Flow platform. But we don't want to push Flow. Flow is a good tool for data collection, and it's not a database. So you know, it depends on the situation. But it's possible to do that, and also in Lumen, the data visualization program, Lumen will basically be capable of importing different data sets from World Bank or Flow or any other data source. That's the idea, because it should be a flexible platform.
Yeah? final question, Brigitte?
Yeah, very impressive suite of tools for water quality testing. I was curious what specific part was funded through via water in the proposal?
We have 3 partners so far who invested quite a lot. That is Akvo, SNV, Akvo. Those are the 3 partners, with SNV the biggest proportion. But those 3 partners really helped us in kicking off Caddisfly. At the same time we are piloting Caddisfly with lots of other partners, but partners who really contributed to R&D are those 3. Other partners through piloting, but that's where we learn how to improve, get field data back experiences, and improve the hardware and improve the software. But that's less R&D, less R&D focused.
And who exactly do you envision to be your end users, your customers? How would you
We are focusing on the intermediates like we're doing with Flow. So our partners who are actually part of a consortium who are doing the actual data collection, so it's the intermediate, we call them the intermediates, so the local partners of UNICEF, or the local partners of SNV, of any other organization, GIZ or whatever. So the enumerators who are already out in the field doing the data collection, but different to Flow. For Caddisfly, in the future it will also be possible to simply buy the hardware and do the test yourself. So if you're on household level, you want to do a test on fluoride, in the future you can order the hardware. The hardware will always be supported by an underlying opportunity to upload the data to the Flow platform. But if you don't want to, we don't force you to. But there's always a possibility to upload household data to Flow. That's really part of the buying price of the hardware. So then it's on household level, more business to consumers instead of business to business. What we're currently in.
Thank you very much. If you have any additional questions, I don't know if you have 10 minutes more if people want to have a chat or share your email address. If you have any additional questions, thank you so much, you for your attention. My apologies for the 10 minutes overtime that we took, but I think it was worth to let the discussion go. Thank you very much.
I deliberately focused a little bit more on content instead of the glossy folders. But if somebody's interested in a leaflet or whatever, just grab one.